So in this session, we are going to see the concept of queue. We are going to understand the concept. So as I always say, we need to understand the concept first so that you will be able to implement in your programming language. So I've put down the pointers again, the pointers which are important and essential for you to know about the topic. So one by one, we are going to go with each pointer and try to understand what exactly is queues. So the very first point that I want to mention is queue is a data structure. We are studying data structure, right? We have already seen stack. If not, you can go and check the videos. So here, a queue is a type of data structure. We know that a data structure will store data in a particular structural format. One of the type is queue. Now let's try to understand how is this data stored in queues. Let's go point wise. The very first point that we see is it is non-primitive and linear. Non-primitive, we discussed it last time as well. When we say primitive data type is integer, character, float, right? Non-primitive data, we have earlier seen the concept of stack. It is a non-primitive data. And here also, your queue is also going to fall into non-primitive data. With that, linear. Data is going to be stored linearly. So non-primitive and linear is the very first pointer for queues. So for us to understand point number 2, we need to dig down in the topic of queue, structurally how it is shown. This is how your queue would be represented, just like an array. I would not put the elements for now, I'll just show the representation. Okay, memory would be allocated, just like an array. However, this is not an array, this is a queue. Now how do we understand this is a queue? Let's try to understand. There are two things that you have to remember here is front and rear. Front and rear. Front is something which is going to help us to point at the start of the queue. Rear is something which will go on incrementing as and when you go on inserting the elements. Suppose the very first time, now here there is one more point that I have mentioned here. Initially front and rear should be -1. So let's start with that. Our front and rear is going to be -1. That means our front and rear are pointing somewhere here outside the queue. Now the moment I want to insert the element inside this, my front and rear are going to point here. Clear? Next, when I want to insert the element, so I have already incremented it. My front and rear are pointing here. I'll insert the element. Now I want to insert the second element. Now in this case, my rear is something that will go on pointing further. My front will remain at the same place. Rear will go on incrementing. So rear will point over here and then I'll insert 20. Rear will point further. Then I'll insert my next element. So in this case, our rear goes on incrementing. Am I clear? When I'm trying to insert the element, my rear goes on incrementing. And when I want to delete the element, suppose this is my rear for now. When I want to delete the element, now when I want to delete it, I cannot delete it from rear. When I want to delete it, as per this particular definition, I cannot delete it from one end. The other end will be used for deletion. So this is my other end. So my front will be something that will start working now. So if I want to delete the element, what I'll do, I'll increment my front. And then this element is deleted. Just like stack, you were decrementing the top and your element was deleting just like your top. So here you are going to increment your front. Am I clear on that? When I want to insert the elements, I will increment my rear. When I want to delete the elements, I will increment my front, not decrement. Decrement will go behind. Increment my front. I want to delete the next element. I will increment my front. And then this element is automatically deleted. Clear? So that is the concept of queue, where insertion permits insertion at one end and deletion at other end. Then again there's one more, again there are pointers over here, same front and rear. End at which deletion takes place is front. Similarly, end at which insertion takes place is rear. So if I want to put the element, I'll have to increment the rear and then insert the element. Initially, your front and rear are always -1. That is what I was talking about. Your front and rear, when there are no elements in your queue, your front and rear will always be -1. The numbering is like just like an array: 0, 1, 2, 3, 4. It looks also like an array. But the execution, the concept, how does the concept works? Insertion from one end, deletion from other end. Right? So that is the concept of queue. Front and rear initially are -1. When you want to insert the element, first you have to increment your front and rear, both. Pick them up and put it at 0. So your second point would be what? Front equal to rear equal to 0. So now my front and rear are pointing here. I'll put the element, insert function. I'll write a function for insert. I'll insert the element. Now I want to insert my second element. Now here I'm not going to pick up both. Only rear will increment. So at first, execution, your front and rear should come to 0, and then your rear goes on incrementing when you're inserting the element. So your rear will be incremented. Clear? Your rear will be incremented, and your front will also be incremented. When will your front be incremented? When you are deleting. Front will also go further, right? Now suppose if I have all the elements, my rear is here, right? Because the concept says increment the rear, then put the element. So when I want to delete the element, I have to increment my front. Automatically my element is deleted. Fine. So this is how a queue works. Now there are different types of queues. We are going to see each one of it conceptually, and then later on switch to our functions. So in our next video, I'll be putting up functions which are included for queues. The basic functions that would be there is insertion of elements, deletion of elements, traversing through the queue, peek function. These are the basic functions that would be used in queues, and those functions would be put up in the next video. So please go through the concept so that when we see programmatic execution of it, it becomes much more easier.